Addressing modes of 8051 microcontroller. Explanation of addressing modes. Addressing modes are an aspect of the instruction set architecture in most central processing unit designs. The various addressing modes that are defined in a given instruction set architecture define how machine language instructions in that architecture identify the operands of each instruction. We are going to define addressing modes in different way. The addressing mode specifies how to calculate the effective memory address of an operand by using information held in registers and or constants contained within a machine instruction or elsewhere. One more way we are going to define addressing mode, how different ways the memory will be utilized. So this is the definition of your addressing modes. Types of addressing modes: register addressing, direct addressing, indirect addressing, immediate constant addressing, relative addressing, absolute addressing, long addressing, indexed addressing. Register addressing. Register addressing is defined as the information transferred between the two registers. Example, move R0, A. The explanation of this instruction, the content present in the accumulator which is transferred to the R0 register. Direct addressing. This mode allows you to specify the operand by giving its actual memory address or by giving its abbreviated name. Example, move A, P3 or move A, 020H. So in this type of addressing mode, the address is specified within the instruction as a part of the instruction. The address is directly specified as a part of the instruction. So move A, P3. P3 is a direct addressing which the content present in the addressing is moved to the A accumulator. Move A, 020H means the 020H is data will be moved into the accumulator. Indirect addressing. This mode uses as a pointer to hold the effective address of the operand. Only registers R0, R1 and DPTR can be used as a pointer register. These pointers are used to represent the memory address. The R0 and R1 registers can hold an 8-bit address, whereas DPTR can hold a 16-bit address. Examples, move at R0, A. The explanation of this instruction is the content present in the accumulator which is moved to the memory which is represented by the R0. Move X, A, at DPTR. The content present in the memory address which is represented by the DPTR is moved into the accumulator. The next addressing mode is immediate constant addressing. This mode of addressing uses either an 8-bit or 16-bit constant value as the source operand. Example, add A, #030 hexadecimal. The content of 03 which is added with the accumulator content. That is the operand having a direct data which is a part of the instruction. One more example is move DPTR, as 0FE00. The 16-bit data which is present in the part of the instruction which is added with the DPTR content. Next is relative addressing. The relative address is defined as is used with some type of jump instructions like short jump and conditional jumps like JNZ, JZ, JC, JNC. That is jump on non-zero, jump on carry, jump on non-carry, like this. These instructions transfer control from one part of a program to another. The destination address must be within -128 to +127 bytes from the current instruction address because an 8-bit offset is used. 2 power 8 equal to 256. Example is given as go back DECA, that is decrement A. JNZ go back. So here JNZ is replaced for the relative addressing mode. JNZ is jump on non-zero. Next is absolute addressing. Two instructions associated with this mode of addressing are absolute call and absolute jump instruction. Using these two instructions we are denoted as a absolute addressing. Example, A call port INIT. Port INIT should be located within the 2K. Port INIT move P0, as 0FS. So here A call will represent the absolute addressing. Long addressing. The long addressing mode which is used with the long call and the long jump instruction. It is a 3-byte instruction and the last 2 bytes specify a 16-bit destination location where the program branches. It allows use of the full 64 kilo code space. the program will always branch to the same location no matter where the program was previously. Example is L call timer init. Timer init URL T mod as 01 hexadecimal value. Here L call represents the long addressing. Indexed addressing mode. The indexed addressing is useful when there is a need to retrieve data from a lookup table. A 16-bit register holds the base address and the accumulator holds an 8-bit displacement or index value. The sum of these two registers forms the effective address for a jump or MOC instruction. Example, move A, as 08, offset from the table start. Move DPTR, has 01F0, the table start address. Move C, A, at A plus DPTR, gets target value from the table start address plus offset and puts it in A. After the execution of the above instruction, the program will branch to address 1F08H and transfer into the accumulator the data byte retrieved from that location. So here indexed addressing mode is useful when there is a need to retrieve the data from the lookup table. Thank you.